Okay, welcome to the Introduction to ElizaOS video series. In this video series, I'm going to be talking about ElizaOS and how you can build AI agents using this framework. So, at the time of recording, the current stable version of ElizaOS is V1. There's a V2 update coming pretty soon, but a lot of the concepts in V1 are backwards compatible. So, everything we discuss here is still going to be relevant with V2, but V2 is going to unlock some more features when that does come around. A quick introduction to what this first episode will be about. So firstly, I'm just going to give you a brief overview of ElizaOS and what it is and how it works. We'll talk about some alternatives for building AI agents, platforms like n8n and LangChain, and what the differences are between ElizaOS and those alternatives. We'll talk briefly about TypeScript, which is the coding language that ElizaOS is built on, and what the advantages are of using TypeScript. We'll talk quickly about the learning outcomes. So this video series, we're going to run through the whole process of building an AI agent from scratch. So all of those features that are available within ElizaOS v1, we're going to implement them, and I'll show you some examples of how all that works. So I'll run you through the full learning outcomes. I'll also quickly show you some definitions around the core concepts of ElizaOS. I'll go into a bit more detail about exactly how everything works, and then I'll show you the architecture overview and sort of how everything ties together for building AI agents. So by the end of this video series, you'll have a lot of knowledge about ElizaOS and how it works, and you'll understand the process for building AI agents on the platform and all of the different features and plugins that are available to help you build a really powerful AI agent. So shortly I'll jump over to Cursor IDE, which is where I'll talk through most of the video. There's a lot of assets I've created within Cursor, so I can run through a lot of those files, and we'll run some commands and we'll actually build an AI agent. So enjoy. Okay, so we're over in Cursor now. You can see I've created a project directory here for the tutorial. So just as a side note, I will be pushing a version of this repo to GitHub at some point. So if you do want to clone the repo and jump in and have a look through all these files and examples and go through the tutorial yourself, you'll be able to do that. There's a document here, followalong.md, which allows you to essentially go through the tutorial at your own pace and perform the commands that you want to perform to build the agent yourself. So that's going to be available at a later date. Let me know if you want me to prioritize that, and I'll get that pushed to GitHub as soon as I can. Just as a starting point here, obviously for episode 1, which is just about what is ElizaOS. First, as I mentioned, there's obviously alternative solutions to ElizaOS. The main ones that mostly used are LangChain and n8n. There are some key differences between these platforms, and there's strengths that ElizaOS has over some of these alternatives. So let's have a look. So LangChain is fantastic for building LLM workflows and chains. So that's what you'd use if you were, processing documents or creating data pipelines, things like that. It's not necessarily designed for creating AI agents with a character and personality. You'd essentially need to build your own management system for characters and multi-platform deployment and conversation memory yourself if that's what you wanted to deploy with LangChain. So it's more so for building out those workflows. There's also a lot of development work required with LangChain. There's a lot more coding that you would need to do if you were going to build a project. You're essentially building from scratch. You can use a lot of resources that are available in the ecosystem. There's still a lot of development work required. So it's definitely not a no-code solution. It's at the other end of the spectrum where there's going to be a lot of coding required. Obviously, you can use tools like Claude to help you code, but it is a lot more code-heavy in terms of the solution. The benefit that ElizaOS has in relation to LangChain is that it does have those agent personalities built in and the character features, and it has all of those plugins built in for deploying across multiple platforms like Twitter, Discord, Telegram, and maintaining that consistent character across all of those different touch points. The other benefit is that ElizaOS has persistent memory, so it's going to remember conversations and learn from that, and all of those features are built into the ElizaOS ecosystem. LangChain's not set up to work like that, although you could build that out, but again, that's going to take a lot of extra coding and development to get to that point, whereas ElizaOS has that ready to go out of the box. We can then compare to N8N, which is another very popular platform. This is like a visual workflow automation tool. So N8N is really good for building out workflows. So if you want to automate a process, it's really good to use N8N. You can drag and drop nodes and build out that process within N8N. So if you want to connect APIs and automate workflows that rely on APIs, it's really good for that, but it's not really built for conversational AI or any real multi-agent systems. It just gets a lot more complicated, and it's essentially like Zapier in a way that you can just automate processes. There's no real ability to build out a multi-agent system or an agent personality, and there's no built-in memory system, so you'd have to sort of start from scratch to build any kind of intelligent conversation management tool. If you're building from scratch with either of these tools, it's really typically a 5 to 6 month journey. You need to integrate platform SDKs for Twitter, Discord, Telegram, build your own memory management, create authentication systems, handle deployment and scaling, design conversation flows. All of that stuff would be required to build an AI agent with conversational AI and memory management. Using ElizaOS, you can do that a lot quicker. So all of those features are available out of the box, so you can just create your own project as a plugin and access these features and then set up and have a working AI agent within a week. So that's what you'll see through the rest of this episode. We'll build out an AI agent using ElizaOS, and we'll show you how it works. So again, just to recap, the benefits of ElizaOS: you can be production ready in days, not months. All infrastructure is handled automatically. There's battle-tested platform integrations. Sophisticated memory systems are included in that initial, and it has enterprise deployment capabilities. The advantages of ElizaOS is that you can have a complete AI agent operating system rather than just a framework. The architecture is designed specifically for agent personalities in multi-platform deployment. It's a TypeScript first developer experience, but with the advancements in Claude Code and tools like that around coding, you can really build on ElizaOS without any extensive developer experience. It's obviously not going to be a no-code solution, but with the support of Claude Code, you can make it a low-code solution where you can give Claude Code instructions, and prompting is probably the most important and valuable skill to learn, and then all you need to be doing then is checking work and implementing and testing. So that's the difference between those tools and the benefit of ElizaOS, which in summary is just a quicker way to deploy these AI agents and have a lot more sophisticated features and capability that's designed specifically for that multi-platform deployment and persistent memory and personality. Right, so now we'll quickly talk about TypeScript and the TypeScript advantages. So again, as I mentioned, tools like Claude Code are making it really easy, or a lot easier now, to do your own coding without as much coding experience as a full-time senior developer. So it's not obviously a no-code solution, ElizaOS, but it's almost a low-code solution in my mind when you do pair it with tools like Claude Code that can do a lot of the coding for you. So the most important and valuable skill to learn now, I think, is prompt engineering. If you can get really good at prompting Claude Code and other AI tools, then a lot of the coding can be done for you, and you don't need to have that full developer experience, and you don't need to do any of the coding yourself. You can just check the work that Claude Code does, review it, test it, and make sure it's working. So this is just a quick overview for those people who maybe haven't used TypeScript before. The first thing is type safety. So when you're building agents that need to run 24/7 in production, runtime errors are unacceptable. That would obviously cause the agent to stop working. The advantage of TypeScript is that it catches these errors at compile time, so it'll notice those errors before they can actually crash your agent. So if you try to pass a string where a number is expected, for example, TypeScript will tell you immediately, so you can catch those in advance. Secondly, the developer experience is really good. It's You get IntelliSense and auto completion for every ElizaOS feature. Real-time error highlighting is available in your IDE. Powerful refactoring tools can safely rename functions across your entire code base. And integrated debugging is also available with source maps. Again, Claude Code as a pairing with ElizaOS makes all of that a lot easier as well. There's also a lot of available packages in the TypeScript ecosystem. So if you want to build on top of ElizaOS, which is a pretty common use case, then there are a lot of TypeScript packages available. So again, you could sort of eliminate a lot of that coding and development work by leveraging some of those. Okay, so now I just want to run through quickly here what the learning outcomes are for this video series. So as I mentioned briefly, at the moment it's designed to be a 10-episode learning journey that will give you all the knowledge you need around Eliza V1. The first 3 episodes will cover the foundations of ElizaOS, so I'll run you through in depth about the architecture, the CLI for rapid development, and I'll show you how to design compelling agent personalities. TutorialBot, which is what we've named the AI agent for this tutorial, will evolve from a concept to a character with real personality by the end of the series. Those first 3 episodes will really explore that foundational setup, which will also include TutorialBot being deployed. Episodes 4 to 6 will focus on integration and intelligence, so we'll deploy TutorialBot across Discord, Twitter and Telegram. We'll implement memory systems, so TutorialBot remembers conversations and learns from documents, and we'll set up production databases for real-world deployment. Episodes 7 to 10 will cover advanced topics, so we'll then look at building custom actions that give TutorialBot unique capabilities. We'll create plugins that will extend functionality. We'll even integrate blockchain features just on testnet for this tutorial. And finally, we'll implement enterprise-grade security and deployment strategies. So we'll be running through this entire system, including API integrations, real-time system architecture, production deployment. I'll be running through the terminal commands and the process I go through with Claude Code as well to build and deploy an AI agent on ElizaOS. Okay, so next we'll quickly define ElizaOS, and I'll just expand a bit more on exactly what it is and what it can do. ElizaOS is fundamentally different from traditional frameworks. So think of it like the difference between building a car from individual parts versus getting a fully assembled road-ready vehicle that you can just customize. ElizaOS is the latter. All of that is already built, and then you can just build on top of it and deploy a really sophisticated AI agent using the existing infrastructure. So the infrastructure layer we can see here, it handles all the complex plumbing, so networking, memory and platform connections. It abstracts away the low-level implementation details, and it provides stable tested foundation for agent development. So again, on V1 we can deploy a stable AI agent using the ElizaOS infrastructure. The runtime environment provides the execution environment where agents live and operate. So this is where you can manage the agent lifecycle, memory and resource allocation. And it also handles concurrent processing and optimization. So the plugin ecosystem, think of that like an app store where you can add capabilities. So the community can also build open source plugins that you can use and leverage. There are some existing plugins out of the box that you can use. They're pre-built tested modules for common functionality. And as mentioned, there's community-driven development and sharing as well for additional plugins. And a lot of Web3 plugins are being built to support a lot of on-chain activity. There's also a management interface, so the professional UI for monitoring and controlling agents, which I'll show you later on. Real-time performance metrics and debugging and visual configuration and deployment tools. So again, we'll touch on some of these details in later episodes. There's a complete CLI and debugging environment. So there's now an ElizaOS CLI, so you can run commands directly from your terminal to start Eliza. There's hot reload development workflow available too, so we don't need to rebuild every time we make an update. There are some cases where we will need to, but for a lot of it, hot reload's available. Comprehensive testing and validation is also built in to Eliza. So the traditional framework is you build the infrastructure and the agent. The ElizaOS difference is that you configure the agent with the existing infrastructure. So we'll go over here now to ElizaOS Explained, and again, all of these documents will be pushed to Git at some point if you want to run through on your own. But let's just have a look now at the traditional chatbot versus the ElizaOS agent framework. So traditionally, you can handle one platform at a time, manually manage the conversation state, build everything from scratch. Chatbots have limited memory and learning. They can't remember past conversations or learn from past conversations, typically. There's complex deployment and scaling issues. It's restricted to basic chat interactions a lot of the time. There's no built-in document processing and limited AI model support. So that's sort of the traditional chatbot approach. Whereas ElizaOS has a lot of capabilities that expand on the existing or the previous chatbot capabilities. So you can see here it's got full-featured multi-platform capabilities, universal AI model support, so you can use any LLM and AI model if you want to. It's got built-in memory management, so again, it's set up already for you to then just set up that memory management using the existing infrastructure. It's got document intelligence built in as well, so it can easily ingest and interact with PDFs and other documents to use for context and memory. It's got a modern professional UI, so that's the dashboard that's been redesigned for managing agents, which you'll see later on. It's got extensible architecture, so you can create custom actions, evaluators, and clients. So again, that's features that you can use to have persistent memory and learning and build AI agents that can learn from their interactions and improve over time. An enterprise-ready deployment is available as well. The key features is the universal platform support, as we mentioned, the ability to use any AI model, the plugin ecosystem, so that's extensible with things like blockchain and trading and social platforms. Developer experience, again, as I said, TypeScript, bun, hot reload, and the comprehensive CLI are all features, but with Claude Code you can turn that into a low-code solution essentially. Some real-world applications. So what we could do with ElizaOS, we can build intelligent chatbots, autonomous agents, business process automation, video game NPCs, trading agents. We can build an agent specifically for knowledge management or for blockchain integration. So these are use cases obviously, but you can combine many of these to build a really sophisticated AI agent that can perform many tasks, and a lot of these do overlap where you can build, blockchain integration with a trading agent and some of those autonomous agent features, so that you could theoretically build a trading bot that would look at the rules you set it and perform trades based on those rules, learn over time from its trades and those results, and change its strategy potentially based on what works and what doesn't, and over time become a really sophisticated trading agent. So again, as mentioned, there's obviously, if you were going to try and build something yourself from scratch, you're looking at a 5 to 6 month deployment timeline. Even if you did use other tools like LangChain and LangGraph, for example, you're still looking at a long process, given that platform requires a lot more dev work up front. Benefit of ElizaOS is that we can use the development CLI to deploy an AI agent within a week. So here's an overview of the essential process for building on ElizaOS. Day one, you can install the CLI and create your project. So you can see here, ElizaOS create my agent is the command you would run once you've set everything up to build your project. Day two, configure character and environment. Character.json file, which we'll dive into later, is how you can set up your character. Day three, add platform integrations and plugins. So this is where you would then configure Discord, Twitter, Telegram, and then add any desired plugins. And day four is testing and deployment. So that process can be done within 4 days theoretically, where you install ElizaOS and set up your project. You then build your character using the character file, so you give it specific rules and message examples and personality traits and things like that, which we'll dive into a lot more in the next few episodes. Once that's all built and set up, you can then configure your API connections with platforms like Discord, X, and Telegram, and then start testing and deploying. So that's how quickly you can set that up to then be, automatically posting on X or engaging with users on Discord with that personality and that persistent memory management. There are some technical prerequisites for ElizaOS. You do need Node.js and Button Package Manager installed. We'll go through that during the setup process. I've already got all of this installed, so it should just already say that I've got it installed, but I'll show you how you would go about installing it. The ElizaOS CLI, so you also need to install that, which I'll show you how to do. You'll need API keys for your desired AI models and platforms, and you will need WSL2 if you're on Windows. But as mentioned, I'll be coding and building this tutorial project on Cursor, so I'll do everything within this project. So that's a bit of a more in-depth review of what ElizaOS is. So hopefully now you've got a good idea of exactly what ElizaOS is and what its capabilities are. Okay, so I'll quickly touch on some of those key features again here before we dive into architecture. So as we can see here, the universal platform support is one of the key features. So as mentioned, one agent with access to multiple platforms and the ability to maintain consistent personality across all platforms. Universal AI model support. So it's really easy to switch between model providers if you want to do different testing. It's just a matter of changing your API keys and the command of what model that the agents should use. Intelligent memory with RAG is another feature which we'll dive into a bit later and show you how to build that memory database. It's got enterprise grade capabilities, which we've already talked about, and the plugin ecosystem is another key feature. So you can see here there's core plugins that exist out of the box. Blockchain, for example, there's a Solana plugin, Discord client, a Twitter client, and a Telegram client that you can set up to easily connect and give access to those platforms. We can also see there's AI enhancement plugins that exist, image generation, speech, and PDFs. So those are some of the key features. Now we're going to dive into architecture and talk a bit more about how the modular components all work together. Alright, so now we're in the architecture overview document. The thing we're going to look at here is how all of the components work together. So you can see here in this overview, we've got the ElizaOS agent. It's got the actions, evaluators, and services. We can see the agent runtime is then what powers the agent, and then we've got providers, the external platforms that it can connect to. So think of ElizaOS architecture like a human brain with specialized regions within. So the actions, what the agent can do. The evaluators are how it thinks and analyzes. The services, the background processes that keep things running. And the providers is what helps it gather contextual information. So you can see here how they all work together. The actions, evaluators, and services at the front end here. The benefit of this modular approach is the separation of concerns. So each component has its specific job. That makes debugging easier and makes them a lot more effective when they can focus on a specific task rather than trying to do everything. Reusability is another key feature. So actions and evaluators can be shared across different agents, so you can deploy them across multiple agents if you're building different characters within the same project. Add new capabilities without touching existing code. So again, that plugin ecosystem allows you to add features and test and deploy without touching any of that base code. And you can test each component independently. So this approach allows you to sort of focus on new features that you add that aren't going to break the entire code base during that implementation and testing phase. Given that modular approach, you can just test almost separately from that that main agent system so that you can isolate any issues and fix them before you do deploy. We'll go now a bit further down here and we can see a flow diagram here of how things work. So let's say the user sends a message on Discord, the context data where the providers would then activate to share user info and knowledge. The evaluators would analyze and learn from that conversation, which that would also come later. It would then have actions that it can execute, such as replying or sending a message. The response would then be generated and sent back to the user. So this would work in a loop where it evaluates the response and learns from the conversation each time. So this section could almost come here later. Kind of makes sense there. Again, if this is a loop, think of it as a loop. So you've sent that message, the agent sent the message back to the user replies, the agent then gathers that info and knowledge and context from previous conversations and the rest of the conversation, then evaluates the response based on the knowledge it has, and then decides what the correct response is in response to that initial message from the user. So the actual implementation looks a bit like this. The providers work in parallel, so it's using the knowledge RAG system and any external APIs and context data in parallel as it also gets the user profile and that specific information. It then uses the evaluators to understand things like sentiment, entities, learning, and intent and priority, and then it would then decide what the appropriate response is and send that back to the platform. In terms of the performance timeline, this is just an overview of how long it might take the agent to respond. This is kind of just a rough guide of how it can work in some circumstances. So you can see all of those actions that we've mapped out there can be executed very quickly. So having the providers work in parallel as well as the evaluators allows the agent to work really fast and reply almost instantly. So the power of the AI agent is how quickly it can process all of that information and generate a response and reply back to the user. Now we'll dive a bit deeper into some of those features that we've talked about, in particular the actions, evaluators, services and providers. So again, think of the actions as things that the agent can do. We can see here continue, ignore, send token are some of the built-in actions that an agent can do, and then we've got things that you can build in as well, like book a meeting, analyze document, check weather. Those are some things that you could build in if you want it to have more advanced capability. As you can see, the three built-in actions are continue, so keep the conversation flowing, ignore, skip this message, or send token. So that's for blockchain interactions. So that's just an overview of how actions work. Then we've got evaluators. So these are the thinkers. That's the processing of information and context and memory before generating a response. They can analyze message sentiment, so they can understand whether a message is positive, negative, or neutral. They can analyze user intent, so understand if it's a question, a request, or a complaint. They can analyze important entities such as names, dates, and places, and conversation context and history. So again, as we talked about, it does have that persistent memory. So from a user's message, it can analyze all of this information in this evaluator phase to understand what sort of message is being sent and who's sending it and what the previous conversation and history is that could influence how it would respond. Next, we've got services. So services are essentially the workers. They're the background workers that run continuously. Things like social media monitoring, scheduling tasks, data synchronizations, and health checks and performance monitoring. External API polling, for example, is a service that might run continuously in the background. You've got an AI agent that is monitoring a token price and is going to trigger a trade once a token hits a particular price. One of those services might be external API polling, where it's checking Jupyter to see what the price of a token is, and it's going to execute a trade once it hits that target price. The providers then are the informers, so this is essentially the information gathering systems. We've got things like user preferences and history, real-time information, knowledge-based content, and external system data. These providers are used for that memory system that you can build so that the AI agent has access to a lot more knowledge that it can access and use to influence how it will respond. We've then got the plugin ecosystem, as you can see here. So, as mentioned, ElizaOS has a modular plugin architecture. So we've got core plugins that exist, AI services, as we mentioned, image generation, speech, video generation, social platforms, data sources, so Birdeye, Dextrina, CoinGecko, blockchain plugins, and then custom plugins that we can build. So the community has already built a lot of custom plugins as well. A lot of those you can access and use within your AI agent platform. Okay, so let's look at a data flow example to see how an AI agent might work in real time. So let's say a user jumps onto Discord and asks your AI agent, what's the weather like? Step 1 is the message arrives via Discord. Step 2, runtime will receive and route the message. Step 3, the providers will then supply the user's location preference and the current time and time zone. So those are key data points for returning an accurate answer of what the weather is like. Step 4 is then the evaluators, so they'll determine the intent of the message, which in this case is a request. And if we've built a weather bot, for example, that might be assigned weather request. And location, so using those providers, we assign a location to this user based on the information we have. Step 5 is then actions, so it executes the check weather action. That would trigger fetches the weather data based on the user's location and time zone, formats a response, and then sends the response back to Discord. So we can see in this example how the providers, the evaluators, and the actions all work together to understand the message intent, get the information that's required to give an accurate answer, which in this case is the location and the time, and then return with an accurate response using the check weather action. Just a high-level overview of here of how it might work. You can input documents such as like a PDF, for example. The RAG system will then extract and clean the data, chunk it into data by semantics, index those chunks, and then store that in the vector database, and then create embeddings. So essentially what you then have is that all that information from that PDF document is chunked and built into a database that the AI agent can use whenever it needs to answer a question. So the query and retrieval flow using RAG might be the user makes a query, you have a similarity search from the RAG database to identify if there's any information in the knowledge base that matches the query. Context assembly is then triggered, and then an enhanced response comes out at the end. So think of that as, let's say you've got the document that you import into the RAG database is a README with all of the information on a project. If the user then asks a really specific question, so in this case, let's say it's the ElizaOS README we've imported, and the user asks, how do I create a new project? The RAG database, you could search that to find the ElizaOS CLI reference, which talks about creating a new project using that ElizaOS CLI command. You would then assemble a response using that information that's been retrieved that matches the similarity search from the user query, and then return an enhanced response, which would be along the lines of ElizaOS has a built-in CLI, this is how you install it, and this is how you would create a new project. So as an overview, the RAG capabilities that exist, document processing and vector search, as we've talked about, allows you to build a knowledge base that the AI agent can access. So if you're building it for a specific reason, a specific project, you can build your own knowledge base and direct the AI agent to reference this knowledge base as a first checkpoint to make sure that you're getting accurate responses for any user requests. Again, we can see here now moving on is that This is just an overview of how TutorialBot might work with access to multiple clients. So you can set up those clients as we discussed so that it can operate on Discord, X and Telegram. It'll have the same personality across different platforms and have specific rules or goals to achieve on these different platforms, and it will still maintain that same personality even if the rules or the objectives it has is different. So for example, on X the goal might be to reply to threads or post updates, daily or every couple of days, whereas on Discord it might be to engage directly with user requests. So those two tasks are very different, but the same personality would persist across both platforms. Okay, so now we can have a look at the development workflow. So this is just a high-level overview of how the process works to create a project on ElizaOS. And again, the purpose of this episode is just an introduction, so we'll dive deeper into each of these phases in future episodes, but this video is just to give you a high-level overview, just to show you how it works. So also to get you familiar with the ElizaOS CLI commands. So step one is obviously to create the project, and we can see here the CLI command you would run to do that is ElizaOS create and then the name of your project. Step two is to configure your agent. We can see ElizaOS env edit local is the command you would run there. Step three is to add components. This is where you would build out the actions, evaluators and plugins for your AI agent. You can then move on to testing, which is phase 4. ElizaOS dev is how you would hot reload to test during the testing phase. You can then run tests with ElizaOS test, deploy to production using ElizaOS start, and then monitor and debug using logs, metrics, and ElizaOS agent list. So that's a sort of high-level overview of the main commands that will be used for these different phases of the project build. We've now got a detailed CLI workflow. I won't go through this one by one. We'll go through these in future episodes and learn how all these work. Okay, so now we'll jump into a configuration example. And the key takeaway here is that you're not writing complex infrastructure code. You're just configuring JSON files. So ElizaOS handles all the parallel processing, plugin integration, and performance optimization automatically. The main thing you're doing here is just updating this JSON file to build your AI agent character. So you can see here, this is an example I've quickly built for WeatherBot. We mentioned the example about checking what the weather was. So here's an example of how that might look in the character file. You name the character, in this case WeatherBot. Clients is where you can add whatever clients you want to use. So again, we've talked about, for example, Discord. If you want it to be active on Discord, that's where you would enter Discord as a client. Model provider is where you can determine what model provider you want to use for the response generation. So in this case, OpenAI, but whatever model you want to use, you can input there. Talked about the plugin ecosystem. So this is where you would assign the plugins that are available for this AI agent. In this case, web search is a plugin that's available for WeatherBot so that it can search the web to get accurate weather. You might even have a specific plugin to a weather site or a weather platform to get accurate real-time data on what the weather is. We've also got settings here, so this is where you would put your secrets actually in the .m file, not in the character file directly. You would have a placeholder here to your .env location. We've then got bio and lore, so again this is how you define the personality type of your AI agent. In this case, the bio is helpful weather assistant that provides accurate forecasts. I can check current conditions and multi-day forecasts for any location. The lore then is trained on meteorological data and weather patterns, always provides temperature in both Celsius and Fahrenheit. Again, so bio is what the agent is, and then the lore is of course kind of history, I guess, in terms of just interesting facts about the AI agent that you want to include that it can potentially reference in some responses that it generates. We've then got message examples, so you can create examples here for the AI agent to use as context. So if there's a specific way you want it to respond and speak to people, you can assign that here using message examples. In this case, we've assigned a message example here. If someone asks what's the weather like in New York, a response we send might be, let me check the current weather in New York for you. We'd probably just reply directly with the forecast, given how quickly it can fetch that data and respond, but that's just an example. Okay, so now we can have a look at what the configuration actually provides. So we've looked at the JSON code. Now we can have a look at exactly how that's operating on the back end. So client section where we are assigning clients to the AI agent, there's 10,000 plus lines of infrastructure code just when adding Discord and X. So client configuration with proper authentication, the platform API integration with rate limiting, platform specific message formatting, connection pooling and error recovery, webhook handling and event processing, all of that is handled by those clients. The plugins, we've also then got 5,000 plus lines of functionality, so the web search API integration, result processing and formatting, rate limiting and caching, error handling and fallback, search result optimization. That's everything that's included just in that web search plugin. And as mentioned, there's a plugin ecosystem that exists where there's a range of plugins that we can use to build our AI agent just by assigning that plugin and building that capability into the AI agent section. We've then got actions, so check weather is obviously, we've talked about how that works. It would have weather API calls and data processing, location resolution and validation, response formatting and presentation, and error handling for API failures. Providers, those are the context gathering systems, so we've talked about how they work, and the evaluators are also built into that. So the takeaway, I guess, here is that you write 10 lines of JSON, maybe more than 10, but it's not a lot. And what ElizaOS provides is a whole lot of infrastructure that's tried and tested. So it's essentially minutes or hours instead of months to set up an AI agent, and this is the configuration file that we'll be working with when we do build out our AI agent. So I mentioned we'd be building an AI agent as part of this tutorial. This is the starting TutorialBot character file that we've created. We'll build out this over time, but this is a starting point of how it looks. So I'll quickly run through how we've set this up, and then I'll go through how TutorialBot will evolve over the course of this video series. You can see here we've named it TutorialBot. We haven't assigned any clients yet or set up the model provider. I've just got the Bootstrap plugin for the moment. So the bio, hello, I'm TutorialBot, your friendly companion for learning ElizaOS. I'm here to help you understand AI agent development from the ground up. I'm built on the same enterprise-grade architecture that powers trading bots and business automation agents. Right now I'm simple, but I'll evolve with you through each episode of this tutorial series. The law is then, as I said, that background information about the AI agent, in this case created as a learning companion for the ElizaOS tutorial series, represents the journey from concept to enterprise-ready AI agent, demonstrates the power of ElizaOS's modular scalable architecture, and will evolve from v0.1 to v1.0 over 10 episodes, gaining new capabilities along the way. At the moment, the knowledge the AI agent has is ElizaOS architecture and concepts, AI agent development best practices, tutorial progression and learning objectives, which are within this directory, and common development challenges and solutions, topics that it can discuss. ElizaOS development obviously is the main one there. We've also then got a style, so be friendly and encouraging, explain concepts clearly and patiently, show enthusiasm for learning and development, reference your own evolution and growth. So we'll be able to chat with TutorialBot and ask questions about ElizaOS, and it will be able to respond and answer our questions. The chat style is to use encouraging step-by-step explanations, ask if the user needs clarification, celebrate learning milestones, and be patient with beginners. Then got adjectives, helpful, educational, patient, encouraging, enthusiastic, supportive. So should be a good learning companion. And then we've got message examples. So we can see here, as in the message examples, we've just got, I'm new to AI development. Is this tutorial series right for me? And the example response, absolutely, this series is designed for beginners. I'll be evolving alongside you, starting simple and building complexity gradually. We'll go from basic concepts to enterprise-ready agents together. Don't worry about your experience level. I'm here to guide you every step of the way. So if we now jump over to evolution, we can see here how TutorialBot will evolve over the course of this video series. We can see in episode 1, the status is just the basic shell, which we've just had a look at. The capabilities, basic conversational responses, understanding of ElizaOS concepts, friendly, encouraging personality, and awareness of learning journey. The character focus is simple, curious, eager to learn. Episode 2 will become a CLI-ready agent. The growth there will be more structured, follows CLI patterns. Episode 3 is rich personality. That's when we'll look at the character file and build out more of its personality. So the distinct personality of TutorialBot will emerge then. Episode 4 is multi-platform capable. That's when we'll help it adapt to different social contexts. So as we mentioned earlier, the way it responds and interacts with users may be different from X as opposed to Discord and Telegram. Episode 5 will explore memory and learning. So that's when we will enable memory for the AI agent. So it will have persistent memory, conversation history, the ability to learn from interactions and knowledge accumulation. Episode 6 will look at production database. So this will be around enterprise-ready foundations in terms of data storage, robust persistence, and performance optimization. Episode 7 will then look at custom intelligence. So this will be behaviors and responses in regards to custom actions, sophisticated evaluators, intelligent decision making, and behavioral complexity. Episode 8 will then look at plugins. So we're going to look at the plugin ecosystem integration, extended functionality, modular enhancements, building a really enhanced AI agent with those community tools. Episode 9 will then look at blockchain enablement. So we'll look at blockchain interaction, transaction handling, safety protocols, and risk management, which is 2 really important things to consider with any blockchain integration. And then episode 10, it'll be enterprise ready. So we'll look at security, full audit logging, and those enterprise features. So that's what we're going to do. That's the sort of journey we're going through with TutorialBot through this video series. So again, we'll start pretty simple. This episode's just been an overview essentially of ElizaOS and how everything works, and then we're going to really dive in deep and set everything up and build this AI agent throughout the video series. So the purpose of this tutorial is that as TutorialBot evolves, so will your understanding of ElizaOS and how the architecture and components all work together. The AI agent development patterns, the production deployment strategies, important security and safety considerations, community and plugin ecosystem integration. So by episode 10, the aim is that you'll have both a fully functional AI agent and a deep understanding of how everything works together in the ElizaOS framework. So just to recap, hopefully now you've got a pretty good understanding, a high-level overview of how ElizaOS works. The next phase is to actually build our project, so that's what's going to happen in episode 2. You can see here in the Getting Started file that I've got open now, we can see what commands we need to run to install ElizaOS and create our project. So these are the commands we'll be running at the start of episode 2 as we start the build process. But yeah, hopefully this video has given you a good overview of ElizaOS and what its features are and how everything works. If you've got any questions, drop them in the comments below. Otherwise, stay tuned for episode 2. Also, just a heads up, if you want to be notified as soon as new videos come out, head to SnapperAI.io. You can join the waitlist here. All you need to do is put in your first name and email, and you get email notifications as soon as new tutorials or courses or repos become available. So head on over there if you want to sign up and get notified.